Hello everyone. In this video we will do examples of integrations in which we will do a mixture of what techniques we had, and we have to go one by one on the strategies we established so far to be able to evaluate the integral. So let's look at the first integral that we have here. It's a multiple of x times sine squared x cosine x. Well, it's not in the table, it's not, simplification wouldn't work here, it's not one of the forms that we usually see, and this obvious substitution, there's none there I can apply. So now it's go back to the substitution and integration by parts and make sure that we have tried all the possibilities. Here, I want you to remember that when we had some x multiplied to sine x, we did integration by parts. And then integration by parts killed that x, and then we gave us some integral, simple integral. So that same idea can be seen here. Now I want to go get rid of that, so that x there. Integration by parts I want to apply. So I want to put u to be x such that when I do the integration, differentiation, or maybe 5x, let me just put it there, 5x. Then when I do find du, I get rid of x. Then the rest, which is sine squared x and cosine x dx, would be my dv, yes? From there, I can go find v, which is integral of sine squared x cosine x dx. You may say that, okay, so how are you going to integrate that? But if you look carefully, this is a trig integral, and it's one of the simple ones actually, the one that cosine has a odd power. So you just set t equal to your sine, and then that way the integral will turn to t squared. And from that, that's 1/3 of t cubed plus c. I can now put this one back. So let me just put this one down here. Remember, I did substitution here. And then I pull it back up there without c because I don't need to have c there. This will give me 1/3 of sine to the power 3x plus c. Okay, so now I have back to this part. I can apply integration by parts. U v minus integral of v du, which is 5/3 sine to the power 3x dx. Okay, so this is 5x/3 sine to the power 3x minus 5/3. You see, integral of sine to the power 3 is one of another integral that we know how to integrate it, yes? So this one, I will go separate one power of sine, and then the rest of the powers, which is sine square, I write it in terms of cosine. This way I can use u substitution. U substitution to be, I'm doing several substitution for this integral. So u to be cosine x, then du is negative sine x dx. So if I apply that, my integral will turn, I'm going to bring this down for all the cases. That negative sign, I take it inside so that I have, oh, did I put minus sign there? I forgot it. I said, but I forgot. So that will be plus 5/3, 1 minus u squared du. Now I can integrate that. 5/3 u, which is just cosine x, minus 5 over 3, that's 5 over 9 cosine to the power 3x plus c. So you see, in the integration by parts itself, we did a substitution, yes, first. And then when we found v, we applied IBP, and then the integral we found itself needed some substitution. So mixture of all the tricks and strategies we knew from before. Okay. How about this one? Integral of sine inverse square root of x dx. You can go ahead and try to see if this will work for the general, the substitutions that we know, or IBP maybe. I will start with the substitution here because that root x tells me that maybe that's a good substitution there. So substitution, I'll put root x to be my variable t. Then dt is 1 over 2 root x dx. Okay, I don't have enough things there, so I will multiply the whole integral by 2 root x, and then 1 over 2 root x dx integral. So this is 2t sine inverse of t dt. When we do this step, then it should come to you that, okay, there is 2t there and sine inverse. Remember that we have sine inverse itself. We did integration by parts for sine inverse. Here now, we will do integration by parts. And remember, integral derivative of a sine inverse is something 1 over root 1 minus t squared. So that is good, or that is telling me that sine inverse x is better to be u, so that we get rid of that 1 minus, we get rid of that trig function in our integral. But then the rest will be 2t. Oh, this was in t, sorry. That's my bad. This t. And then the rest will be v is going to be integral of 2t dt, which is t squared. Now, having all this set up, we have a t squared sine inverse of t minus integral of t squared over 1 minus t squared under the square root dt. Okay, at least now I turned my integral after several things, doing a substitution and integration, but I turned it into an integral that I know definitely the substitution, the trig substitution, would turn it back to something interesting. What would I take here as substitution? So I will take u. Okay, I will use u this time. U to be sine x. Then this will tell me that du is integral of cosine x dx. And well, let me just write this integral here, t squared over root 1 minus t squared dt. Oh, I'm doing trig substitution, so t must be equal to sine of theta. Sorry about that. Then dt is going to be cosine theta d theta. That's the whole point of being here. So here now this is sine squared theta over 1 minus sine squared theta. Here will be cosine theta d theta. Integral of sine squared theta, And then this square root of 1 minus sine squared and cosine are the same, so they will cancel each other, and I have just a simple integral. Well, even powers of sine, I know that I have to use the half angle formula, then integrate that, and then that will give us cosine of 2, sorry, sine of 2 theta plus c. Okay, I'm not done. I have to turn back everything into a t at least. So here basically I set t over 1 to be sine theta. So this will be 1 minus t squared. And sine theta is 2, sine 2 theta is sine 2 sine theta cosine theta. So this way we have the integral half of sine inverse of t minus 1 over 2 sine theta is just t, that part is 1 minus t squared, and then plus c. Okay, we evaluated that, but you should remember that our original function was x. So if I want to write the result here, actually this is good. I can push this a little bit down there. Yes, other than that one, everything worked nicely. Now I can go ahead and come back from this here, everything here. I can write that this guy is instead of t, I'm going to write root x. So this will be x sine inverse of root x minus half of sine inverse of root x minus half of, oh, there's another minus there, multiply, so that will be plus root x root 1 minus x, and then plus c. And I'm not saying that this is the only way to integrate, but this is one of the ways. I just wanted to show my flow of thoughts and just making some trial and error thing and get what we found here. Okay. Let's do one more example. Root x e to the power root x. Before I have gone through this thing that whenever there's e to the power something or e to the sine of something, those are good candidates for us. So let me put t equals to root x. As a result, dt is going to be 1 over 2 root x dx. And as you see, I need something more there, so I multiply the whole integral with, or the integrand with 2 root x and divide it by 2 root x. So this way my integral, see here, this is going to be du, so that is du. This x and that root x, they will multiply, you get x, and x is what? X is t squared. So this will give me 2t squared e to the power t. Oh, this was dt, sorry. So this is one of the forms that I know integration by parts will work for that, and I will go ahead and use that, but I will need to use twice. A polynomial times e to the power t, you need IBP, but the number of times you have to apply it is the degree of that guy there, so t squared, which is 2. So u is 2t squared, du is going to be 4t, dv is e to the power t dt. V is going to be e to the power t itself. So now I can write this down. 2t squared et minus integral of 4t e to the power t dt. I need to do another integration by parts there. So that will give me 4t e to the power t and minus integral of just 4 e to the power t dt. I didn't write the details this other time, so this is another IBP. And that will give me 2t squared e to the power t minus 4t e to the power t minus 4 e to the power t plus c. If I factor out e to the power t, I get this polynomial times e to the power t plus c. And okay, don't forget that I have root x there, so this will give me 2 root x squared. I'll write just x minus 4 root x minus 4 e to the power root x plus c. And yes, that is how you combine different things, substitution, IBP, maybe several IBPs, and you get some of these results.